Hello, welcome to Maths with EJD. In this video, I'll be talking about one-way ANOVA. Well, ANOVA is still under what you can consider parametric tests, especially for more than two groups. Okay, so let's go for that. What is ANOVA in the first place? Okay, ANOVA, is the of analysis of variance. So it means uh it's the name is self-explanatory, right? We analyzing variance. So let's see specifically what it is. ANOVA actually is a statistical technique. It is a statistical technique used to determine if there are significant differences between the means of three or more groups of three or more groups. So remember that uh things like t-test, z-test are just meant for two groups. But here, once you have three or more groups, you can talk about ANOVA. Okay. So it assesses the impact of one or more factors by comparing the means of different samples. Okay. By analyzing the variability. So that's where the variance comes in. By analyzing the variability within and between groups. So within and between groups. By analyzing the variability within and between groups, ANOVA, ANOVA can help, ANOVA can help decide if the observed differences, if the observed differences in group means, if the observed differences in group means are statistically significant. All right. So that's what ANOVA is about. So let's talk about types of ANOVA. Types of ANOVA. So there are several types. There are several types of ANOVA, each suited, each suited to different experimental designs. Each suited to different experimental designs. Okay. Um, the first one is the one-way ANOVA. One-way ANOVA. Of course, that's what our focus is on in this video. So one-way ANOVA. So this actually compares the means, of three three or more independent groups. So if the groups don't have anything in common, then you can use it. Three or more independent groups based based on one factor. I think that's the key word. One factor or one independent variable. One independent variable. So it tests if at least one group mean one group mean is different from others. Okay, it's different from others. So the aim here is even if you have three or four, five groups, so what this testing is at least one is different from the rest of them. So as far as one is different, that is what the test is about. Okay, so we have another type of ANOVA, which is the two-way ANOVA. Two-way ANOVA. And what does this do? Two-way ANOVA assesses the effect, it assesses the effect of two independent factors. Two independent factors on a dependent variable. So you want to see how two independent factors affect a dependent variable. One way ANOVA, one factor on one independent variable. Okay, so it can also evaluate the interaction. So the interaction between the two factors, between the two factors. So for two-way ANOVA, you have a dependent variable, two independent variables. Let's say student performance is the dependent variable, and then you have two independent variables like nutrition and say hours of sleep. Okay, so if you want to access the effect of nutrition and hours of sleep on student performance, so you need to use two-way ANOVA. And in using two-way ANOVA, it can also show you the interaction between nutrition and hours of sleep on themselves like that. Whereas for one way ANOVA, right, you just want to see the effect of nutrition on student performance, and that's all you're checking. You know. All right. So that's two-way ANOVA. Of course, we have a third type of ANOVA, which is what you can call repeated measures. Repeated measures ANOVA. Repeated measures ANOVA. This is used. This is used when the same subjects, when the same subjects are tested under different conditions. Under different conditions. Okay, I mean this sounds like what you do under paired t-test or uh paired z-test, when you observe the same group, the same subjects under different conditions or at different time points. So repeated measures ANOVA would be something similar to paired test, like maybe it's paired T or paired. Of course, it will be paired T if you have data less than 30, and it will be a paired Z test when you have data like 30 upwards. So this helps. It helps analyze. It helps analyze the differences. It helps analyze the differences across multiple measurements. Across multiple measurements. So here now you have the same group and you're taking their data at different points, maybe at three or more points, and then you can do a test on that. So that's why it is called repeated measure. So maybe you have a group of students and you want to see their performance. You see their performance in year one, you see their performance in year two, you see their performance in year three, you see their performance in year four, and then you want to do an analysis on those different time points. That will be repeated measures ANOVA. And we have the fourth one, which is called the multivariate ANOVA. Multivariate, multivariate ANOVA. You can call that MANOVA. Multivariate ANOVA, which is MANOVA. And what does that do? It actually extends. It extends ANOVA to multiple dependent variables. Multiple dependent variables. So you're no longer looking at just one in a dependent variable. So extends ANOVA to multiple dependent variables. Okay. Testing, testing for differences. Testing for differences in vectors, of means. Okay. But I mean, for the purpose of this series, I'm going to just focus on one-way ANOVA and two-way ANOVA. So this video is going to focus on one-way ANOVA, and later I'll come up with a video for two-way ANOVA. So let's go on with one-way ANOVA. One-way ANOVA. one-way ANOVA. So, one-way ANOVA, I think we have a hint of that already. One-way ANOVA is one of the simplest forms of ANOVA. It compares the means of three or more groups to determine if at least one group mean if at least one group mean differs from others. Hmm. Differs from others. For instance, suppose we want to test if different teaching methods, if different teaching methods, if different teaching methods A, B, C result in different student performance levels, Okay, so in that case, we use one-way ANOVA. All right, so let's talk about the concepts involved in that. So talk about the concepts involved in one-way ANOVA. First, as usual, since it is a parametric test, right? It falls under hypothesis testing. So you can say that is not, you have, of course, your hypothesis. So the null hypothesis, H naught actually assumes that all all group means are equal. So what that simply means is that H naught is such that mu1 is equal to mu2 is equal to mu3 is equal to all the mu's up to mu n. Okay, so that's what the H naught is in this case. Then we have the alternative hypothesis. Alternative hypothesis. That is H1. Okay. Now in this case, this is used. Okay. Sorry. The alternative hypothesis would be that at least one group mean, is different. At least one group mean is different, such that H1 will be at least one mu I differs. So that is the alternative. Now, we also have the F statistics. This is the measurement. This is the test statistic for ANOVA. It's called the F statistic. This is used to determine. If the observed differences, are statistically significant. Okay, it is calculated as the ratio of variance between groups, ratio of variance between groups to variance variance within groups. Okay, that is the idea of F-statistic. Now, let's look at some assumptions. Let's look at some assumptions of one-way ANOVA. Assumptions. Of course, all of these things are based on certain assumptions. So the first one is this: independence of observations. I think that's fundamental. Independence of observations. Unlike repeated measures ANOVA, in one-way ANOVA, you have independence of observations. So it means that the observations have nothing in common. The observations, the observations in each group, the observations in each group should be independent, should be independent. Okay. Then another point is that uh, we assume normality. We assume normality. What that means is that the data in each group, the data in each group should be approximately normally distributed. Approximately normally distributed. So that's the assumption of normality. Then we have homogeneity of variances. Homogeneity of variances. Okay. So the variance within each group, the variance within each group should be roughly equal. Should be roughly equal. Okay. Now let's talk about the steps. What are the steps needed to perform one-way ANOVA? Steps to perform one-way ANOVA. Okay. So the first thing is calculate the mean, calculate the mean of each group, calculate the mean of each group, okay? And the overall mean, that's the first thing. And the overall mean, that's the first thing. The second thing is to calculate the sum of squares, the sum of squares, the sum of squares between groups, sum of squares between groups. That is called SSB, sum of squares between groups. That is SSB. And the third point is, okay, of course, this is how the SSB is calculated. SSB is equal to the summation from I equals 1 to K, then NI into XI bar minus X bar all squared. And in this case, okay, I think I should just do this. XI bar is the mean of group I. The mean of group I. So if you have group 1, that would be X1 bar, group 2, X2 bar, group 3, X3 bar, group 4, X4 bar, and so on and so forth. Whereas X bar itself, X bar is the overall mean. X bar is so this is overall mean. Okay. And then NI is the number of observations in group I. Number of observations in group I. So if you have 3 observations in group 1, that'll be 3. If you have in group 2, okay, N1 will be number of observation in group 1, N2 is number of the observations in group 2, and so on and so forth. So that's what the formula looks like. Then the next thing, after calculating the sum of squares between groups, you also want to calculate the third thing. You want to do the third, go to the third step, which is to calculate the sum of squares, sum of squares within groups, within groups, sum of squares within groups, that is SSW. So, and for that, um, the formula is simply SSW equals summation from I equals 1 to K. You know, it is within groups now. And summation from J equals 1 to NI K of, then that's Xij minus Xi bar all squared. So here, Xij now is the jth observation. So this is the jth observation, the jth observation in group I, the jth observation in group I. So for instance, X12 is the second observation. X11 is the first observation in group 1. X12 is the second observation in group 1. Then something like X23 will be third observation in group 2. So third observation in group 2. And then we go to the fourth step. Of course, you already know Xi bar is the mean of group I. I think we've seen something like that before, so there's no need to bother about that anymore. So the fourth step now, step 4, is to calculate the total sum of squares. The total sum of squares, which is SST. So, and that's simple. SST is just sum of squares between groups plus sum of squares within groups. So that is SST. Then step 5 is to calculate the mean square, the mean square between, that is MSB, and the mean square within, and the mean square within. So the mean square within would just be MSW. Okay. Simply MSB is equal to SSB over K minus 1, whereas MSW is SSW divided by N minus K. All right. So here, K now is number of groups, and N is number of observations, Okay. Number of observations. Then, okay, I mean, it is the total number of observations, very important. So if you add up all the observations, that's the total number of observations. Then we go to step 6. Step 6. So step 6 is to calculate the F statistics. Calculate the F statistic. Calculate the F statistic, which is given as F, which is mean square between all over mean square within. Then number 7 is to compare the calculated F statistic to the critical value from F distribution table, Okay. I mean, that's the usual thing. So if the calculated F is greater than the critical value, as usual, we reject we reject the null hypothesis. So usually for the null hypothesis to be accepted, the calculated value should be less than the critical value. Alternatively, so if you don't want to use the calculated value and all that, you can use the p-value. Alternatively, if the p-value, if the p-value associated, if the p-value associated with the F statistic, with the F statistic is less than the significance level, p-value less than significance level, which is commonly, it doesn't have to be, but it's commonly 0.05. In that case, we reject H naught. Okay. So you can either use critical value compared with F statistic, or you use p-value associated with the F statistic and the level of and the significance level. Okay, significance level, which is commonly taken to be 0.05. So that goes. Now let's take an example. Let's take an example and see how that works out. All right. Example. Suppose suppose we have three groups. Suppose we have three groups of students who were taught using three different teaching methods. Okay. The test scores for each group are as follows. So those who were taught with method A, they had 85, 90, 88. Those who were taught with method B had 78, 82, and 80, respectively. Those who were taught with method C had 92, 94, and 93. Okay. Now the question is, we want to test, we want to test if there are significant differences in mean test scores, across the three methods. Okay. Now let's go on to to deal with this. Okay. So step one, calculate the group means. Yeah, I mean before I go to this, I think it's important. We've seen like those 7 steps. I think there's a very nice way to put this down. Okay. So we can have I guess I should have even written before the example. It's okay to here. So we can have a very nice table like this to present our work. Source of variation, we have that. Let me just leave the source of variation. Then you have sum of squares, source of variation, sum of squares. Okay, that's your SS. Then we have degrees of freedom. That's the next thing, degrees of freedom. Okay, I want to really save space. Let me do it again. Need to save space here. Okay, so now source of variation. Let me keep this tight enough. Source of variation because I want to save space. Then we have sum of squares. These are your SS's. Then you have degrees of freedom, degrees of freedom, your DFs. Then you have mean squares, mean squares. These are your MS's. And then you have your F statistic finally. That's the goal. F statistic. So, something like this. Now, so first you can have for source of variation, the source of variation can be between groups, okay? And between groups now you have sum of squares between, and you can have degree of freedom between groups, okay? Degree of freedom between groups, and then you now have mean square between groups, okay? Then next another source of variation can be actually within groups, and then you have source of sum of squares within, degree of freedom within it still, and then you have mean squares within, okay? Then lastly, okay, so you have some kind of total also. So now this would be the total. Of course, this is SST, which is the sum of SSB and SSW, like we saw before. And then this is DF total. That's the addition of DF between and DF within. And then, of course, here we don't have to worry. We know F now is MSV over MSW. So this is like a table to summarize the things you have to do in answering a question. Okay, so let's go. Um, let's do this. The first step, like we know, is to find the means. I want to find the means. Yeah, so step one, step one, calculate the group means. Calculate the group means. Calculate the group means. That's step one. So there are three groups, right? We have 85, 90, 88. So let's just do all that. All that. XA bar is simply 85 plus 90 plus 88 divided by 3. And that should be, we need to be sure. Let's be sure about that. 85, 85, oh, oh, 85, 85 plus 90 plus 88 divided by 3. That is 87.67. 87.67. Then XB is 78, 82, 80. So 78 plus 82 plus 80. Easily that should be 80 because they are evenly spread out. That's 80.00. And we have XC. XC is 92, 94, 93. 92 plus 94 plus 93 divided by 3. So that's also evenly spread. So 93.00 is easily the mean for those three. Now the next thing is to calculate the SSB. SSB. So step two, step two, step two, calculate SSB. That's sum of squares between. And how do we do that? Oh, okay, yeah. Sorry. Step two should be to calculate the overall mean. Calculate the overall mean. That means the mean of means, right? So we can add these three together and divide by three, or we can add all the numbers we have. So that's x bar now is equal to 85, you know. Um that is 85 plus, okay, so that will be 85 plus 90, 85 plus 90 plus 88 plus 78 plus 82 plus 80 plus 92 plus 94 plus 93 divided by 9, divided by 9. So that'll be x bar equals 85, 85 plus 90 plus 88 plus 78, 78 plus 82 plus 80 plus 92 plus 94 plus 93, all divided by 9. So that should be 86.89. 86.89. On the average, that's 86.89. That is the overall mean. Of course, another way to check that is you can add those three averages you already had. You can add them and divide by 3. So you can check that way to see. So we have 86, 86.67, 86.67, 86.67 plus 80 plus 93 divided by 3. And that is what we have now, 86.89. Of course, the value will be different a bit because of approximation. But I mean, it's basically 86 point something. So if you do everything together, that's even better. All right. So the next step is you have step 3 now. Step 3. So for at step 3, this is where we calculate the sum of squares between. Step 3, calculate SSB. Calculate SSB. And to calculate SSB, this is the way to go about it. SSB. Sum of squares between. Calculate SSB. That's the next step. Just a minute. So calculate SSB. Um, okay. Trying to get this out. Okay. So calculate SSB. All right. So for SSB now, you remember the formula up there. The formula for SSB is this Ni xi bar minus x bar all squared. So to calculate SSB now, SSB is equal to from summation from I equals 1 to k of Ni into xi bar minus x bar all squared. And I think we have all the information needed to do that. So this means we have SSB now to be equal to, of course, like if you have N1, so in short, this would be like N1 into X1 bar minus X bar all squared plus N2 into X2 bar minus X bar all squared plus N3 into X3 bar minus X bar all squared. So that means SSB is equal to 3. So group 1, each group, N1, N2, N3, they're all, so we already know that N1 is equal to N2 is equal to N3, and that's 3. It doesn't always have to be like that, so be watchful. So you have 3 into X bar, X1 bar minus X bar. That is 86.67 minus 86.89. 86.89. The first one is 6.67 minus 86.89. All this squared plus 3 into x2 bar is 80.00 minus 86.89 all squared. Then 3 again into uh 93.00 minus 86.89 all squared. So that SSB is equal to 3 into 86.89. You want to make sure of that to avoid mistakes. So this would be 86.67 minus 86.89. So this is it minus 0.22? Minus 0.22. So is it 86.67? 87.67. Sorry, that's my mistake. 87.67. 87.67. 87.67. Okay, that is, let's do that again. 87.67 minus 86.89. 87.67 minus 86.89. Okay, that is 0.78. 0.78 squared plus 3 into, okay, 80.00. That's just 80, right? 80, that's 80 minus 86.89. 80 minus 86.89. That is minus 6.89 minus 6.89 all squared again. Then um we have, I'm suspicious of something being wrong here. How could that be? 86.67, 87.67, 87.67, 87.67 minus 86.89. Okay, that is 0.78. Okay, yeah, that's okay. Then plus 3 now into 93, 93, 93 minus 86.89. That is 6.11 squared. 6.11 squared. 6.11 squared. Okay, so we can go back and iron out all this. So we have okay, let's just do let's do everything together. We have 3 times 0.78, 0.78 all squared. Okay, that is 1.82. So all of that is 1.8252. 1.8252. The next one is 3 into 3 multiplied by minus 6.89 minus 6.89 all squared. So that is 142.4163. And lastly, we have 3 times 6.11 all squared. That is 111.9963. 111.9963. so that SSB now is just the sum of all of these things. So we have 1.8252 plus 142.4163 plus 111.9963, and that is 256 point, this is 256.2378. Okay, so this is SSB. Okay, as between now, between groups. Now let's talk about within groups now. Within groups. So for within groups, we have that's step 4 now. So step 4, calculate SSW. Calculate SSW. And again, the formula for SSW, you remember, is this. SSW is equal to summation from I equals 1 to K, then summation from J equals 1 to Ni, then Xij minus Xi bar all squared. So if you want to break that down, so we are saying that SSW would be, so if you take J to be 1 now, uh, from I equal I to K, I'm trying to break this down to make it more meaningful. Let's K coming in here. Okay, K, we already know K is the number. K is the, yeah, I think K is the number of groups. So if you have 3 groups, so for instance, um, okay, so when I is 1, for instance, so it means we have X, X1, when I is 1, so we have X1, that is group 1, right? So X1, so we have X1, 1 minus X1 bar all squared plus X1, 2 minus X2. Okay, this should still be X1, right? So minus X1 squared plus X1, 3, minus X1, okay, bar now, X1 bar squared. Now, this is for group 1. We are talking about within the groups now. This is for group 1. So for group 2, it will be X21. When K is now 2, I mean, when I is now 2, so we say X2, then the first element minus X2 bar squared plus X22 minus X2 bar squared plus X23 minus X2 bar squared. So you see, so this one is consistent with this now. Then this group 2. So this is first element in group 2, second element in group 2, third element in group 2. Then for group 3 now, for group 3, we have X31 minus X3 bar, X3 bar squared plus X32 minus X3 bar squared plus X33 minus X3 bar squared. That's plenty. That's a lot. Okay, so let's go slowly. I mean, this is requiring a lot of computation. So let's be very careful with that. So let's do that. SSW now. So let's go as we can. So X11, that's the first number in group 1. So X11 is 85. X12 is 90. X13 is 88. And X1 bar is the average, which is 86.67. So let's do all that. And there we have, 85 minus 87.67 squared plus 90 minus 87.67 squared plus 88 minus 87.67 squared. That's the first one. Next, we go to group 2. For group 2, we have Okay, I mean, we can even use this. For group 2, we have 78, 82, 80. 78, 82, 80. 78, 82, 80. And the average for group 2 is 80. Okay? 78, 82, 80. So we have 78 minus 80 squared plus 82 minus 80 squared plus 80 80 minus 80 squared. That's for group 2. And for group 3, we have 92, 94, 93. And the average is 93. 92, 94, 93. And this is 92 minus 93 squared plus 94 minus 93 squared plus 93 minus 93 squared. Okay. So, of course, we can already see that this is 0. This will cross out. And this will also cross out. So we can focus on the other things. So SSW now is equal to, okay, let's just do the squares and to save time so we don't have to keep doing it step by step. So let's do 85, 85 minus 87.67 all squared. Okay, 85 minus 7.67 all squared. So that is 7.1289 for this. And the next one, we have 90 minus 87.67. So that is 5, 5.4289. 5.4289. Then the third, this now, second, the last one is 88 minus 87.67 squared. So that should be 0.1089. That is for the first group. We are doing within groups now. So the next thing is we have 78 minus 80. 78 minus 80. So for 78, minus 80, all squared now, that should be simply be 4 plus 82 minus 80. As I believe that's another 4. So 82 minus 80 is another 4 because that's 2 squared, which is 4. And plus 0, this is 0. Then the last layer now, 92 minus 93, that's minus 1 squared, which is simply 1. Then plus the next one, 94 minus 93, that squared, that is 1 again. Then the last one is 0. So SSW is obtained this way. So we have SSW now to be 7.1289 plus 5.4289 plus 0.1089, then plus 4 plus 4 is 8, plus 10 in short, plus 10, all of that. So 4411, that's 10. So let's check again. 7.1289 plus 5.4289 plus 0.1089 divided by, plus 10. That is 22.6677. So we can say this is 22.6667. So now that is SSW again. Now we go for so we have calculated SSB, we have calculated SSW. I believe those are the hardest parts. The other parts are simple, simpler rather, so to speak. So you can now calculate MSB and MSW. So these ones are easier. We just need the degrees of freedom now. So again, MSB, going by the formula, MSB, if we follow the formula, is actually this. It is SSB divided by K minus 1. That's number of groups minus 1. So we know SSB already from what we computed up there. That is 256.2378. That's SSB, 256.2378. So 256.2378 divided by K. K is 3 groups minus 1. So that's the number of groups we have. 3 groups minus 1. And then that means we have 2,256.2378 divided by 2. Okay. So 2,256.2378 divided by 2. And that is approximately 128.1189. It's approximately 128.1189. So this is SS. So in short, MSB is 128.1189. Then the next thing is MSW. So again, MSW, the formula is this. MSW is equal to SSW divided by N minus K. N minus K. So of course, N is the total number of data, everything together across groups. And we know SSW is just what we computed now. That is 22.6667. So this is 22.6667 divided by 9. All the observations all together, that's 9. Number of groups, that's 3. So we have 22.6667 divided by 6. 22.6667 divided by 6. 22.6667 divided by 2. That is 11 point. That should be 22.6667. Oh, divided by 6. Sorry, divided by 6. That is 3.7778. That is approximately 3.7778. And so that we have MSW to be equal to 3.7778. Now we are almost at the end of the road. We calculate F now. So calculate the F statistic. That is step 6. Step 6 now. Calculate the F statistic. The F statistic. So that means, and for F statistic, we simply know that is the same thing as MSB over MSW. And we know MSB, what we just got now, 128.1189, 128.1189 divided by 3.7778. So approximately, we have 128.1189 divided by 3.7778. 3.7778. And that is approximately 33.91. 33.9136. So finally, we have our F statistic. So F is 33.9136. So that is step 6. Then next we need the critical value or the p-value. Anyhow, anyone of the two. So let's go to, that's now step 7. So for step 7 now, okay, this is step 6. Step 6. Okay, I think I stopped writing step at this point. So step 5. Step 5. Now for step 7, we want to compare with the critical value. Compare with the critical value. Okay, so at a significance level, of 0.05 and degrees of freedom, of course, K minus 1 now. So K minus 1, which is 3 minus 1, which is equal to 2. So a degree of freedom, K minus 1, which is equal to 2 for the numerator. And N minus K, total observation 9 minus 3 groups, which is 6 for the denominator. for the denominator, for the denominator. So the critical F value, the critical F value is approximately. So if you use your F distribution table, so it will be approximately 5.14. So, and if that is the case, you can say now since okay, now we have F test, that's F test statistic, which is 33.9136, 33.9136. Since F test is greater, so the test statistic is greater than F critical. So the F critical in this case is just 5.14. Then what we just do here is we reject the null hypothesis, reject the null hypothesis, reject the null hypothesis, indicating a significance difference in means, a significance difference in means. So that's the usual thing. Once the test statistic is bigger than the critical value, we reject the null hypothesis. So that means that the teaching methods are at least the one mean is significantly different from the others. So let's talk about the interpretation of results. Interpretation of results. Okay, how do we interpret that result? So since the calculated F statistic, since the calculated F statistic is significantly larger, is significantly larger than the critical value, than the critical value, we conclude that the teaching methods conclude that the teaching methods result in statistically different scores. Statistically different scores. Statistically different scores. So in this case, further analysis, which I'm not going to bother about for now, further analysis such as post hoc tests. For instance, the two keys HSD could be performed to identify which specific group pairs differ significantly. Then final decision. Okay. So final decision, or you can now say the one-way ANOVA, indicates significant differences among the groups, suggesting that at least one teaching method leads to different student performance. Different student performance compared to others. Okay. Again, post hoc comparisons, post hoc comparisons, post hoc comparisons can help pinpoint pinpoint which methods are more effective. Which methods are more effective? Wow, this has been a very long ride. In summary, right, ANOVA is used to compare means across multiple groups. One-way ANOVA tests for differences in means based on a single factor. Then it requires assumptions of independence, normality, and equal variances. The F-statistic helps determine if differences in group means are statistically significant. If you have not subscribed to this channel, please be sure to do that right now and click the notification bell so you can always get alerted when new video is released. Then comment, let me know if you have a question for me to solve or if you have a topic for me to teach. And then don't forget to like and also share so that more people can have access to these things. Thanks for coming this far. It's been a long, long one, but I know it's worth your time. Till I come your way again, keep getting things right. Bye.